Hello. Let's look at sector cone problem or cone transformations. Now, what is a sector? As you know, a sector is a portion of a circle that is bounded by two equal radii. So I think I have a sample of a sector here. Yes, an example of sector. So if I cut out this from this circle, I will have this remaining. If I want to complete this, so now I'm taking this portion out, gives us this, which we have here as you can see. Now, it is possible to transform this sector into a cone. Yes, it is very possible to transform this sector into a cone. So now, this is my R here. In sector cone transformation, now observe this. This is my sector. Let's say I fold this to form a cone. Yes. You should observe, and I have a cone formed this way. Yes. And what you observe here, the cone has a circular base. It is a circle. So what can we deduce from this? Looking at this, if you observe clearly, you could see in a cone, as we know in a cone, that this portion of a cone is always called the slant height. This in a cone, we call this height the slant height. We know that, and we call this the base radius of the cone. And here the height, the perpendicular height of the cone. Yep. So, and if I have a radius, so let's say this one, if I have a sector of radius capital R, and if you observe here, folding this now, if you watch, my R, that is the radius of the cone, now tends to be equals to the radius of the cone, the radius of the sector now tends to be the same thing as the slant height of the cone. Please don't be confused. For a cone, this portion is always called the slant height. And if I have a sector of radius R and I fold this to form a cone, if you fold this, imagine, just teach yourself, if you fold this cone, if you fold this sector, this portion on the side of a cone is still giving us the radius of the sector. So that is why in sector cone problem, the sector when folded, the radius of the sector when folded now becomes the slant height of the cone. So whenever you're solving sector cone problem, the radius of the sector or of the circle is always the slant height of the new cone form. Yes, R is always equals to slant height. In sector cone transformation, R is always equals to slant height. So what other facts do we know here? Now watch here. If you also notice, this length here, I call it LA, length of the arc. This distance here, length of the arc AB, and then this distance here, everything here, this here. Now, if I fold this cone, if I'm to fold this sector, if I'm to fold this sector, if you observe, I will have a circle. How come? This whole thing here is the length of the arc. This whole thing here, when you fold it, this whole thing here now gives us a circle. If you fold this thing here, it turns to a circle. How do I mean? What is the length of, okay, let's use this one. What is the length of the arc here? The length of the arc here, as we know, length of arc is theta over 360 times 2 pi or r, yes, exactly. Theta over 360 times 2 pi r. So this length of the arc you see here, you can see it's in green color. This length of the arc now becomes the circle of the cone form. And everything here seems to look like the perimeter of the circle. Everything here tends to be the perimeter of the circle. So what is the perimeter of the circle? For this circle here, its perimeter is P equals to, it's just 2 pi of this r here. Yes, the length of the circle, its perimeter for this particular circle here is 2 pi r. And like I just said, that what happens in cone sector or sector cone transformation, that the length of the arc now becomes equals to the perimeter of the circular base of the new cone form. So since these two are equal, let's equate them. So I will have that I will say, but we have LA, length of arc becomes equals to the perimeter of the circle. So let's now equate. The length of arc means theta over 360 times 2 pi r. Yes, the length of the arc now becomes the perimeter of the circular base. So what is the perimeter here? It's just length of the arc is now equals to 2 pi r. So from here we can deduce an important relationship between the radius of the sector of the circle and then the radius of the new cone form. So from here we can have this, that 2 pi can cancel out 2 pi here. And what do we have left? We just have theta over 360. We have theta over 360 times r. We have theta over 360 times r, which is now equals to our small r. So therefore, our small r becomes equals to theta times r, should be theta r over 360. So this is another important relationship or formula in sector to cone transformation. So in summary, whenever you're solving sector cone transformation, don't forget your r becomes equals to the radius of sector or of the circle, while the small r becomes equals to radius of the new cone. Yeah, this r means what you must listen to the question when they say a sector of radius. Take it as your r, and your r must always be equals to L, slant height of the cone. So I think it's well understood. So in our next class or in the next video, we shall look at how to solve problems on sector cone transformation. Thank you.